In this lesson, we are going to use Excel to summarize quantitative data. So here in this example, we have the weights of 40 silver quarters minted before 1964. So this is our sample data set. The first thing we want to do is to sort the data in ascending order. So to sort data with Excel is super easy. All we have to do here is highlight all the data. So I'll be highlighting cells A2 to A41. Then we go to the data tab on the top here, click it, and over here you see the sort tab, and the sort A to Z sorts from smallest to largest. Sort Z to A will sort from largest to smallest. We want to sort it in ascending order, which is smallest to largest. So with just one click, we see the data is now sorted, where the minimum data value is 6.0002 and the maximum data value is 6.3669. So now that the data is sorted in ascending order, we're now going to compute the range of the data. And the range of the data is found by computing the difference between the maximum and minimum values. So here in this cell, let's compute the maximum minus the minimum value. So let's just put equals here. So we always precede computations in Excel with an equals. We'll go to the maximum value and just click the cell that contains it. Minus, I will click on the cell that contains the minimum value. We'll hit enter, and we see that the range of this data, the difference between the maximum and minimum values, is 0.3667. Now that we have the range, we can actually use it to estimate the standard deviation using the range rule of thumb. The range rule of thumb says that the range of data is approximately 4 standard deviations wide, and if, in other words, the standard deviation when solved for is the range divided by 4. So we'll estimate the standard deviation by going equals the range. I'll just click on the range value and divide it by 4. So this is just a very quick field computation for the standard deviation that doesn't use the more complicated formula that takes into account every data value and its difference from the mean. So here we will just compute a quick approximation. Range divided by 4, that approximation is called the range rule of thumb. I hit enter and I get 0.09168. So that is our approximate standard deviation for this sample data set. Next, we're going to compute what will be the number of classes that we'll use to summarize this data. In order to summarize quantitative data into a frequency table, we first need to create the classes for the frequency table. The classes are similar to the categories used in a frequency table for qualitative data when you have categories. So to make bar charts and pie charts with qualitative data, you had categories and their associated frequencies. Here, we don't have categories, we just have a bunch of numerical data. So we're going to divide the numerical data into classes where each class will have a specific range of the quantitative data. We need to know how many classes to use, so we're going to use Sturge's formula to do that. Now, Sturge's formula is 1 plus 3.3 times logarithm base 10 of our sample size, which we'll denote with little n. So let's go equals 1 plus 3.3. I can either type the command log 10 or I can go to formulas, the math and trig formulas, scroll down to log, and there's a log base 10 formula. We need the number of data values, which in this case is 40, so I will simply type 40 into the box, and I get 5.9. So we will round that off to 6, and we plan then to create a frequency table with 6 classes. Now, each of these classes will have a specific range of values, and in order to determine how wide this range of values should be for each class, we now need to find an appropriate class width. So the class width is going to be the distance between consecutive lower limits. What I mean by a lower limit is each class is delineated by a lower and an upper limit, and then all values between those and including those endpoints will be contained in that class. So we need to find lower limits, and in order to create lower limits, we need the class width. So the way we create a class width is we take the range of our data, which we computed up here in the second part, and we're going to divide that by our desired number of classes. We say desired number of classes because even though we, for example, have decided on 6 classes, the way we round this width here and how many repeats and such are in the data set, we could actually end up with fewer or more than 6 classes, depending on those certain things, especially how we round our class width. So we will go equals, I will click on our range, then we will divide that by the 6, our desired number of classes, and we get 0.06112. Notice all our data values are to 4 decimal places. We're going to need to round this up, and I think I will round it up to 0.06500. 0.06500. Okay, now I could have also rounded that up just to 0.062 to 0.0625. Almost any value I really wanted to. I rounded it up to 0.065. That may be a little bit too much. Let's go ahead, I've changed my mind. Go with 0.062. So a small rounding up. You always want to round up for your class width, and depending basically on what your data set looks like will help you determine how to round it up. I rounded it up just a little bit. Chances are it will be close to the 6 classes. Rounding it up more, like maybe that 0.065 might have been enough to take this down to 5 classes. Kind of hard to determine in the beginning, but we'll go with the 0.062. Another point I need to make is notice how there was no one correct way to round this up. We could have rounded it up in different ways, so this is now a subjective choice that is made in constructing the frequency table. So different frequency tables can look different. There's not just one correct frequency table. Now once we have that lower class limit, we're going to choose a starting value. I'm sorry, this is our class width. Once we have this class width, we will choose a starting value for our lower class limit and then create all the lower limits. I'm going to do that below here. So let's make a column for lower limits. We will make a column for upper limits, so I will stretch this out. Then we're going to make a column for the frequencies, which is how many data values fall in those classes delineated by the lower and upper class limits. So up here, let's type in classes, and I'm going to go ahead, now we'll just go ahead and leave it there, but let's, no, that's fine. Alright, so we need a beginning value. Now, you can either start at your lowest class value, or your lowest, data value, 6.0002, or you can start with something below that, which maybe 6.0000, 6 even. That is another subjective choice you make, just depending on preferences in your data. So a good starting point for this frequency table, a good first lower limit, could be 6 even or the 6.0002. I like to start mine personally with the lowest limit that we already have, so I am just going to click on the 6.0002. Alright, and now I'm going to use that and the class width to create all the other lower limits until I have 6 of them. I'm going to do that using a formula, so I'm going to click on the previous cell here, and then I'm going to add to it that class width that we've decided on of 0.062. So notice I just clicked on the 0.062 as well to create a formula. I want that 0.62, which is contained in L9 though, to be a fixed value. I don't want it changing to L10, L11, L12, and so on as I copy the formula. So I'm going to do a function F4. So we need F4 to put the dollar signs in front of the row and column designations, and then that kind of fixes or makes that cell constant. So there's 6.0622. And now I'm going to just copy this down, 1, 2, 3, 4, 5, 6, till I have 6 of them. And here are my 6 lower limits. Now, to fill in the upper limits, we simply want a value that is less than the next upper limit and ends that class. So the second upper limit is 6.0622. I'm going to subtract 1 from the last digit to get 6.0621. So see how 622, subtract 1 from the last digit to get 621. And I'm now going to create a formula using that first upper limit and add to it again the same class width, but fix it by doing function F4 to put in the dollar signs to make that cell a constant. Enter, click and drag to copy, and now I have all the upper limits. So notice the largest upper limit is 6.3721. Our largest value is 6.36691. So we see that our largest value does indeed have a class that it fits into, and so this then will take care of all our data values. And we are now finished with our classes by computing all our lower limits and all our upper limits, and we are ready to have Excel compute those frequencies for us. So to compute frequencies, the easiest way using Excel is to use the data analysis tool or add-in that's here. So I showed you in an earlier lesson, lesson 1, how to insert that data analysis tool. So let's click on the data analysis tool, and we actually are going to use histogram to find our frequencies, as well as to give us a preliminary frequency histogram like we were going to want to do shortly. So we'll do both of these at the same time. So I'm going to click OK. My input range is my data set. So I'm actually going to click on A1 all the way to A41. So I've highlighted all my data plus a label. Because I have a label, I click this box here labeled labels, and this says that the first cell is a label, not a data value. Now I'm going to click on the bin range, and what the bins do is basically divide up the classes. It tells Excel how the classes are being divided up, so it knows where the cutoffs are for the frequency counts. So we're going to use the upper class limits as our cutoffs. Since I clicked the labels box here, I also want to highlight the label for upper limits. This is why I put the lower and upper limits in separate columns. I'm going to highlight all my upper limits. So there they are in cells D20 to D26. And now I need to tell Excel where I want my output to be. So I click on the output range button. Now notice it default highlighted up here to your input data. So make sure to click in the output range box so you don't override your input data. And I am going to have it output down here. That'll be my upper left cell. So I just click that and then it'll use adjacent cells as needed. And I want to also make sure we get a preliminary histogram, so I click the box chart outputs and that will give me a preliminary histogram that then I can modify and perfect. Everything is now filled in correctly. We click OK. Here's our preliminary histogram. Notice there are the upper limits being used on the horizontal axis. Frequency, vertical axis. This is pretty good, except we're going to want to close the gaps. And I'm also going to change these upper limits later to midpoints, and I will talk about that soon. So here is our output. It again spits out the upper limits as well as the frequencies. Excel will always give you by default this last category labeled as more, and if you've done your limits correctly, that should always have a frequency of 0. So what I'm going to do is copy these frequencies here, do a Control C, and up into my frequencies in my frequency column, Control V, and there we go. So those are the frequencies. Okay, now since I have my table here, let's go ahead and perfect this histogram. Okay, first of all, I'm going to give it a new name. These are weights of silver quarters. So I'm going to just click on here and type in weights of silver quarters. Notice this didn't change, but as I typed, it went up into this input bar up here. Once I hit enter, it's there. I'm going to make my box a little bit bigger here. So notice how when I get that double white arrow, it'll keep the same aspect ratio as I increase it. I need to close the gaps. So as I am in Chart Tools, once you're clicked in the histogram, you'll see this Chart Tools up here, Design Layout Format. If you click in Design, you will get some chart layouts here. Click on this bottom arrow for more chart layouts, and chart layout number 8 is the preferred histogram layout. So we will click on that, and now we have a histogram here. We could change this by using chart styles to get some contours that will allow us to differentiate our bars. So I click on one of those contours and I'm just keeping it blue, and then here is my histogram. So the upper limits are here, which is fine. However, I prefer to use class midpoints. So over here I left some space in column B, and I am going to type in midpoints. These are the midpoints of the classes. So to find a midpoint, you simply will add the lower and upper limits together. So notice I did equals for an Excel computation, open parenthesis, lower limit plus upper limit. We need to divide that now by 2 because we're finding a midpoint, and the midpoint is like an average of the limits. So there's the first midpoint, and I'm just going to copy down to get all 6 midpoints. Now I want to use the midpoints to label my horizontal axis here. Alright, I want that as midpoints. So going back up to Chart Tools and clicking Design, there is a Select Data box. And what I want to do is edit my horizontal axis. So I will click on Edit. And I want to make sure now that the midpoints are highlighted. So notice I've highlighted the midpoints. Here they are listed. You can even see them already on the histogram. Click OK. Click OK. And now we have the midpoints labeling our bars. So now I need to change this label to midpoints. Notice that got typed up here. So when I hit enter, There are the midpoints. So we now have a completed histogram. Let's go ahead and determine the shape of this histogram. This is sample data, so the shapes bell and uniform would not be perfect. As long as they are approximately bell or uniform, we can call the shape bell or uniform. Notice that this has a rather nice low, high, low pattern, and it is approaching bell. So I can go ahead and say that this is approaching the bell-shaped distribution, bell-shaped pattern. That is the best shape for this data. It's approaching bell, and that is what you would expect with the minting of quarters. So we have our frequency table, the shape, our histogram. Let's now finish our frequency tables by doing 2 more columns. We want a column for relative frequencies and a column for percent frequencies. So here I will do relative frequency, which I will just label as REL FRQ. And a relative frequency is basically a proportion. It's also an empirical probability. So we're going to find proportions. These would be considered sample proportions or empirical probabilities, and can be used later to make estimates and later interval estimates of the mean for this data. But for now, let's just find these relative frequencies. So relative frequency is always the frequency divided by sample size. Our sample size is the sum, which should be 40. Let's go ahead and do an auto sum in formulas to confirm that we have all 40 data values, which we do. So equals, click on your relative frequency cell, divided by click on your sample size. Do function F4 to fix the sample size so that cell designation E27 is now constant and will not change, but the numerator E21 cell will change to E22, 23, and so on as we copy. So there's our relative frequency, 0.05. Click and drag. There are all the relative frequencies. I'm going to round these so that they're all the same, all to 3 decimal places. And since these are relative frequencies or proportions, they should sum up to 1. So we do an auto sum, and we see indeed we got a sum of 1, so everything looks good. Now we'll do a percent frequency column, and we'll simply turn these relative frequencies to percents. So I just want to multiply each frequency times 100 to change it to a percent. So here's 5%, copy all the way down to get down to 10%. Again, I want these to all have the same number of decimal places just because it looks more neat. So I give it 3. And the sum should be 100%. So I do an auto sum to confirm I got 100%. So now we have computed the relative frequencies and the percent frequencies. We already constructed our histogram and stated the shape of the distribution. And now we're ready to find summary statistics using Excel. Again, we're just going to use Excel to find all the summary statistics. Here I'm just showing you how to find them. I'm not going to explain what each of the summary statistics represents. That is in another lesson. So let me click Home. Well, actually, we want to go to Data, and the quickest way is a Data Analysis Tool. So for the Data Analysis Tool, we go to Descriptive Statistics and click OK. Input the range of our data. So I again am going to highlight the label and all my data. I go over here and click the box labels in first row. My data was in a single column. If you had data in multiple columns, you would make sure you click columns. If your data was divided into multiple rows, you would click the rows. I want to have an output on the same page, so click in my output box. Now I will output my sample data down here, and I will fill in adjacent columns as necessary. Make sure to tell it you want those summary statistics. Now click OK, and here are the summary statistics. I have it labeled as weights. That's why I like to click my labels. And we will widen this So we have the mean. I'll just run through these quickly. The mean is your weighted average, or I should say your average of your data values. Think of it as the typical average you learned of in school. Also, it's like a balance point, the way of defining the middle as a balance point. So on your histogram, if you look, you're like, okay, if we would, where would we put a fulcrum to balance this? Well, hereabouts. And notice hereabouts ends up being exactly 6.19, etc. All our data is to 4 decimal places, so we really should round all our statistics, except for the count. That should be rounded to no more than 5 decimal places. So we will round that then down to 5. Whoops, down. There we go, 5 decimal places. Standard error, that is for sampling distributions. Quickly, standard error is simply the standard deviation divided by the square root of your sample size, which in this case is the count. So notice down here we have count 40. That tells us we indeed highlighted all 40 of our data values. The median is the physical middle. So when we look at this all in order, there's 40 values, so in around the 20th value, which would have shown up as 21, notice that the average of the 2 middle values gives you your median. So here's our median, the average at 6.19435. So this here, mean is your average, median, physical middle of data set. Mode, most repeated value, and this means there was no mode. None of our data values repeated. Standard deviation is the sum of the products x minus mean squared divided by actually count minus 1. Alright. Okay, so it's a sum. It's basically almost an average of the square differences of the mean. Okay? So x minus mean squared divided by count minus 1. So not a sum product, just a sum. Oops, my mistake. Hold on. That is Control X, Control V. That is the sample variance. The standard deviation is the square root of the variance. Okay. Square root of the variance, where the variance is the sum of the square differences from the mean divided by 1 less than the sample size. So it's basically a average of the square differences from the mean. We're not going to worry about kurtosis and skewness, but kurtosis is peakedness. Skewness is how far it deviates from symmetry. Range, max minus min. We had computed that previously, where here's your maximum value and here's your minimum value. Sum is just the sum of the data values. Most important here, the mean and the standard deviation. Those are usually always given for sample data sets. One more statistic is the coefficient of variation, which then is a unitless measure of variation. So it's the standard deviation divided by the mean. So if we compute the coefficient of variation, we'd just go equals standard deviation divided by the mean, and the units cancel out, and we have 0.014. This is often given as a percentage, so we can multiply it by 100, and then that would be a percent, so about 1.4%. Right, so there's an example, a quick example of summarizing quantitative data where we compute frequency table with relative and percent frequency columns, and we found our lower and upper limits and midpoints. A histogram, a frequency histogram here to show you the shape of the data, how the distribution looks, and then our summary statistics. This was a quick example. I will be making videos of other examples and explaining the meanings of these sample statistics in more detail.